warm up. Oh. Hi.
Hi.
Thanks. Almost done. Oh, no, it's on. How are you feeling about 67 over 250 for it? I did that without a calculator. So I could have added that. It's not too bad. Hi. Did I do that wrong? Oops. 72, nope. Sorry. There's the reference here. 72. How about 1350? Still no? What's taking so long? Anybody 1350s? Can I get an amen on that? No? Fiftieth? Ray? How are you? Okay, cool. Fourth. Yes. We got, sure. If you want to be a wimp. Yay. Better late than never. Square root of 4,000. 71, 72, 17. Taking will take us so long. Yeah, you're going too slow. 71. All right, how are we at? Where are we at? A, B, C, D? Proceed. 150. Checking your progress. I have 13/50ths for A, 1/4 for B, obviously. C, I got 1/50th. And I'll let you finish D, and then we'll talk about it. I didn't identify M, but remember M stands for the maximum or an upper bound for the second derivative on the interval. It's a max concavity measure is what that stands for. Did you get an M of 6? Okay. And then we're finishing part D, or another minute, or good to go?
No, another minute.
All right, did you get 71 or more trapezoids for part D?
Yes.
All right. Okay, no. N must be an integer, and you always round up. Okay, questions on 7. Cool. The lesson should be a little bit of review, but a little bit of new. Actually, it's mostly review, so hopefully it'll go well. There's a little something new in there that I doubt if you know, but we'll see. So, you've taken derivatives of absolute value. You did it in set 73, I think? 70, maybe 73, I think. So, would you, first of all, crank out the derivative general? What is the derivative? 3x squared minus 1. All right, now, there are 2 places to throw the absolute value on. You could throw it on the outside of the function or around the function or on the x, and they are 2 totally different results. If the absolute value is around the f, then the absolute value is around y, and therefore the concepts at hand are when y is positive, there is no effect. But when y is negative, they get made positive, yeah? So if we look at the graph of this here, y equals x cubed minus x, factored out. Isn't it x times x squared minus 1, or x times x minus 1 times x plus 1, okay? So there's this symmetry and odd function like that. All right. So what about the graph of the absolute value on the outside of the function? What does it look like? Talk to me with some math. The part below -1 gets switched or flipped up. The part from -1 to 0 remains the same. The part from 0 to 1 remains, nope, gets flipped. And the part after 1 is the same. Now then, we could write f in a piecewise function, then take the derivatives in 4 pieces. The part x less than -1, is it, now I'm talking, sorry, absolute value of that. Okay. Is it the opposite of the function or the same as the function? Opposite. So it would actually be x minus x cubed if I switch the signs, okay? The part from 0 or -1 to 0. Opposite or the same? Same, x cubed minus x. The part from 0 to 1. Opposite or the same? Opposite. And from x greater than 1. Same, yay? When I go to take the derivatives of this, then the derivative, using this kind of notation here, the derivative of that is, so what's the derivative of the first branch? Right, 1 minus 3x squared, x less than -1. The next branch is 3x squared minus 1. What about at the flex points? Does the derivative exist? Should I include x in the derivatives at these places where it's getting flipped? No, they are sharp turns, so do not include them in the derivative. They should be included in the function because the function actually does exist there, but on the derivative it should not exist. So we're taking the derivatives, and the only difference is on the domains we're not including the flex points. Right? That's review, and that seems to be going okay. Now let's talk this one. This one's a little harder. When you throw absolute value on the x, if the absolute value is on the x, then for positive x's, there is no change. No change, better. Okay? For negative x's, they get made positive, then they get put into the function. Now that makes things complicated. Let's go back at the original graph. It says here positive x's, there's no change. Where are positive x's? On the right, the left, the top, the bottom. The right. Okay, so this part, there is no change. Positive x's. If I put a positive x in there, the absolute value would do absolutely nothing. I'd get exactly the same y as I did, right? Negative x's are a different story. If I put in a -1, for example, actually, let's say I put in a -1/2. If I put in a -1/2, it would get made into a +1/2, and then I would want f at a +1/2. Well, f at a +1/2 is actually like this point. So every point over here, all these negative x's should look just like the positive x's. And so the graph would look something like this. Negative x's look like the positive x's. All right then. So if I were to write this in a piecewise-y kind of way, and I mean the function, not the derivative, I only need two pieces. The left side for when x is less than or equal to 0. These pieces, are they normal f unchanged, or did f change a little for this left side? How did it change? Opposite. These got flipped up, these got flipped down. Everything is the exact opposite. So it's x minus x cubed for x is less than or equal to 0. Now for the right side, x greater than 0, there is no change. So it's still going to behave like x cubed minus x. You with me? Therefore, the derivative of that function is, so it's the derivative of the first branch. 1 minus 3x squared for x less than or equal to 0, or don't include 0. Yeah, it feels like I got a sharp turn there now, so we're not going to include 0. Then it's 3x squared minus 1 for x greater than 0. We therefore say the function does not exist, or the derivative does not exist at 0. All right. Try one on your own. Try this example, and then I'll teach you something new for those of you who need to be intellectually read every day. Good job. ¿Listos? Let's see. Graph's a little harder on this one, yeah? Where are the flip points? Where's that equal to 0 and then getting flipped? 4 pi over 3 and 5 pi over 3? Are your trig skills there still? Or were they ever there? Okay. All right then. The function in a piecewise fashion is unchanged up to 4 pi over 3, then negated from 4 pi over 3 to 5 pi over 3, and then unchanged from 5 pi over 3 to 2 pi. Yay? You agree? Okay. So f prime then is 0 plus 2 cosine of x. So 2 cosine of x, negative 2 cosine of x, and 2 cosine of x. The only difference being, actually, now what about, the endpoints are kind of funky here. Does the derivative exist there? Is there a flex there, or should I include that? Is the derivative accurate there? Yes. Yeah, so you should actually include the first endpoint, but don't include 4 pi over 3 because that is a flex or a flip spot. then it's 4 pi over 3 to 5 pi over 3 non-inclusive, 5 pi over 3 non-inclusive to 2 pi. On that again, I don't see why non-inclusive. You with me? All right. Now, you can imagine if you're a programmer, how hard it would be to program finding the derivative of an absolute value function. It's highly conceptual, yeah? I mean, you have to find where it's zero, then test the signs to see where it's getting flipped, and then do this for this part, but that for that part. It's a mess. That'll make you appreciate, then, another way that some textbooks, not very common, most textbooks do piecewise, but you will find some textbooks that say the derivative of that function is that. Now think about why that would work. Let's start here. Where's this coming from? This is just coming from the derivative, as if there was no absolute value. You with me? All right, now consider the effect of this. This is so cool. When this expression, or when the y values are positive, is there any difference between the function itself and the absolute value? No. So wouldn't you agree that when the function is positive, these come out the same and you're multiplying by 1 and the derivative is just straight up cosine, right? All right. But when the function is negative, this would be negative, but this would be positive, and the number would be the same, so this would equal -1, and therefore negate the derivative in those sections. Now, isn't that slick? That's pretty cool, right? Are you with me? Okay. That is a common way to find when you are asked to take the derivative of a function in absolute value. You will sometimes see f over the absolute value of f times f prime to deal with that flipping spot. Pretty cool. And a heck of a lot easier program. All right. Let's go to the backside. Check this out. Integrating absolute value. We've done this before. When did we integrate absolute value? So she'll be on the test. When we did what kind of problem? When we did those distance problems, we did without a calculator. Distance is the absolute value of, or the integral of the absolute value of velocity. So we've done this a little before. It won't be super duper new then. I just want to make sure you're really good here. So notice I threw you a bone and I used the same function. We said previously that this function has flip points at 4 pi over 3 and 5 pi over 3, and then heads up again. Now, just like in a derivative, we did it in a piecewise way. Same with the antiderivative. This could be rewritten as the integral from 0 to 4 pi over 3 of normal function or negated function. Normal function root 3 plus 2 sine of x dx plus. Now you could actually put the negative. Do you agree we're going to negate the next part? Yeah. Okay. You could put the negative inside or outside. What do you want to do? Outside it is. Okay. So from 4 pi over 3 to 5 pi over 3 of root 3 plus 2 sine of x. And then last but not least, from 5 pi over 3 to 2 pi of normal, right? Okay, now the question is, do we need to practice that, or that's a big mess and a waste of your time? I got another one you can do on your own. Do you see where you headed from there? Okay, so walking through the steps then, what do we do first? When you integrate absolute value, you first have to, you find the zeros. Okay, a picture helps. Yes. In some cases, all right? Now, once you find the zeros, that tells you the places where it's probably getting flipped up, but you still need to investigate where it's getting flipped by doing a sign test or, again, a sketch to find where it's positive y's and negative y's. to see if it's getting flipped or not. And then you integrate piecewise using the positive y's unchanged and the negative y's negated. Right? All right. Would you try without a calculator? Number 2, or go with the you try probably. Understanding the idea is not the same as being able to do it yourself. How are we doing? My terms. All right, do we agree with 4 log of 2 plus c squared minus 7? Okay, what's another multiple choice using log rules you could see on the AP test? Log of 16 might be a possibility. Okay? All right, last but not least, this is both review of this idea and review for the test. Would you find the average speed without a calculator on 0 to 5? Okay. Are you getting started? Okay, the only way I'm sure that's safe is the average value of the speed function, which is the absolute value of velocity. I wasn't quite sure if I could find average velocity by doing change in position over time and just take the positive. I don't know if that works for anything, so. Yes. What? Oh, isn't that, that's what velocity is. Oh, why the absolute value or why velocity? So the average value of anything you want, of anything, is of that anything, right? That's how you find the average value of whatever you're looking for. Well, what is speed? Speed is the absolute value of velocity, right? And so if you want the average speed, then you need to do the average value of the speed function, which is the absolute value of the velocity. So that's the thought process is I need 1 over 5 minus 0 times 0, 0.5 of 2t minus 4 in absolute value. Are you with me? Okay. Average speed is found by average value of the speed function. Now that is absolute value of the day. That's the topic of the day. It has a 0, I believe, at 2, and before 2, you're talking negative, and after 2, positive. So I'm feeling 1/5 of an integral from 0 to 2 of opposite, 4 minus 2t, and from 2 to 5 of normal, 2t minus 4. If you're a visual person, you could do this graphically and you can see triangles. I'm going to just trust my calculus here. You with me so far? So I'm talking 4t minus t squared from 0 to 2, and t squared minus 4t from 2 to 5. 1/5 of 8 minus 4 minus 0 plus 25 minus 20 minus 4 minus 8. 1/5 of 4 plus 5 plus 4. I'm feeling the average speed is 13/5. Okay, cool? Yes? Okay. All right, that's the lesson. Homework. How did the fun sheet go? Fun sheet, fun sheet. I can. Fun sheet, fun sheet. Yes.
Can I use the restroom?
Sure. All right, last but not least. All right. Doo-doo. Okay, I'll throw out the answers and then you can, we'll go over questions when you're ready. I can do last. Number one, did we do that in class, all parts or just some of it? We did. All right, so A was 176. I do believe we did that in class. B, we found that F double, which was 2 is greater than 0, so F is concave up, which implies that trapezoids will underestimate, right? Overestimate. My bad, you're right and I'm wrong. I apologize. Overestimate. Sorry about that. Okay. And then 2, the exact value is 170 2/3. That then confirms what I would think, which is to say 176 is greater than the true value, and so an overestimate is confirmed, right? You with me? Yes. Okay. 2. Number 2, I have 50.5 or 101/2 if you like. The second derivative of that is negative 12x squared, which is less than 0. That implies F is concave down. Concave down would be underestimate. Traps will underestimate. Right? All right. The true value of that was 53.4. This also is logical. 50.5 is less than 53.4, so trapezoids did underestimate. All right. 3. Here in blue is if I did a right rectangle, then wouldn't I use the right edge for my height? All right. If I use the left Riemann sum, Riemann means rectangle. Left Riemann sum means I use the left edge. That obviously would be a gross overestimate. And then if I use green for trapezoid, it would look like that. Yeah? All right, then, in terms of the greatest to the least, which produces the least? Right. So right probably was the outcome of 0.7811. That's the smallest. The next biggest is trapezoids or left. Trapezoids then probably yielded 0.8675, and left hand were the greatest, 0.9543. All right? Between which two approximations, let's just use the numbers rather than the words. Which is it between? The true error area, is it between traps and right, or what? What do you think? The true area, I'll just say the true area F from 0 to 2 is between 0.7811. It's definitely greater than 0.7811, but less than 0.8675 because it's less than a trapezoid. Yeah? You with me? All right. This one we did in class, I know for sure, right? This guy, I was doing this without a calculator, so hopefully it checks, but we'll see. I got 43.745 meters. Yes? Okay. That one we did in class. It's also, you could have some differences of opinion there. For this one, again, check my work, but I got 80.8 meters squared. I don't hear a lot of, yeah, I got that. Alrighty then. That's unfortunate. We'll see if I have to fix that. Does this table seem to indicate, I can't remember if we did this one. Did we do this one? Oh, so wouldn't you agree that we looked at the changes and the change in F is decreasing? That seems to indicate that F prime is decreasing. F prime decreasing means F double is negative. Yeah? Based on the trichotomy, if something is concave down, as it must be, then trapezoids would underestimate and midpoint would, middle is about here, midpoint would overestimate. So the true value, which you might call an integral, is greater than the trapezoid and less than the midpoint. All right. Part C. How are you feeling about 508? And D. What about 460? No? Not 460? Anybody? What's your answers? 34? 484? Sounds like we got a lot of agreement there. I guess I was a little tired. Okay, 484. That sounds. I still think you must have some mistake somewhere. All right. Sounds like most people agree with that. So we'll go there. Then this multiple choice, some of which I added here. There's a huge part of calculus is the interplay between change between 2 points and change at up points. Sometimes you use change at up point to estimate change between 2 points, and sometimes you use change between 2 points to estimate change at up. In this case, for example, if they want acceleration at time 36, isn't that v prime at 36? And couldn't I approximate that with average change over an interval around 36, yeah? So did you do something like, you didn't need to show all that, but did you do something like the change between v at 40 and v at 32? Over 30 minus 40 minus 32, which is 11 eighths meters per second per second. Do you agree? Okay. Do you have a wavy equal in there? You should not be saying acceleration is equal to that. That is depth. It is not equal to, it's an approximation. All right. Let's go to B. What is the meaning of that? What is the meaning of this? Change in position. You could also call it displacement. Is it also distance? Why isn't it also distance? Yeah, there is absolute value. The absolute value would be necessary. You can see that this is not all positive, so they're not the same. Displacement and distance would be different. So this, now, when you go to explain, like any integral, what it is with units, when it is with units, all four things. So do you have, this is change in position or displacement in what units? In meters, right? From when? Time equal 20 with units seconds to time equal 40 seconds. What it is with units, when it is with units. It's displacement or change in position in meters, time 20 seconds to time 40 seconds. All right? Did you get it as an approximation? Maybe something like negative 75 meters. Again, it's an estimate. Trapezoidal sums are estimates. They are not exact. Do not say the integral equals negative 75. It does not. It's an approximation. All right. B2, this actually has a wording error in it here. I meant given acceleration is increasing on 20 to 40. Sorry about that. Is the estimate over under the true value? Now, if acceleration is increasing, what does that imply derivative-wise? A prime is positive, which means V double prime is positive, and therefore the curve under which we're finding the area is concave up. V is concave up. If V is concave up on that interval, then trapezoids will overestimate. Therefore, trapezoids will overestimate, estimate. So the true value is probably less than negative 75. Okay? Part C. Must the particle change direction? This is a very common point loss, and you might have done the same thing. I'm sure I lost this point the first time I did this. Is it enough to say V equals 0, blah? Does that infer changes direction? It does not. What does that infer? From that, we can infer there's a rest. That is not the same as changing direction. You must state that it changed sign. That needs to be said, not just V equals 0. Okay? So, or if you said something like V equals 0 and changes sign. Now let's go by IVT. Wouldn't you agree there's got to be a time in here between time 8 and time 20 because V changed sign, and a time in here. Now there could be more, so don't say there it happens twice. It should be at least twice. Not exactly twice, I don't know that. So it should be something like at least twice and whatever the time frames are. To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
The Colorado State Patrol Youth Academy is accepting applications until this Friday, March 22nd. Cadets will become familiar with the basic elements of the academy through the demanding daily training schedule. Limited to 45 participants selected throughout the state, applications are online. The academy will be held on July 14th through the 20th.
Something like by IVT because V is continuous. I probably said it that better. D is a humdinger. It was hard. So go here. Acceleration is positive. That implies that V is increasing, right?
No science is required. Simply bring your friends, have some food,
Are you with me?
cheerleading is something you're interested in.
Now V is increasing on 0 to 8. Then on 0 to 8, V must be at least 3 or more on the whole interval, right?
Senior students, All juniors should attend.
So something like this. V is greater than 3 on 0 to 8.
We'll outline how to go through your college planning for next year and reduce your stress.
Now here's where it gets some
Learn
practice.
how to best create your college list and how to
If
best navigate
V is greater than 3, then isn't the integral of V on 0 to 8 greater than the integral of 3 from 0 to 8?
Current 10th and 11th graders who are interested in becoming a girls' mentoring
Follow?
next year, please come to the counseling
From
office.
that, I conclude that the integral from 0 to 8 of V must be greater than
DEF scholarships
What
are
is
due to
this?
counseling the Wednesday
Equal
after spring
to.
break, April 3rd,
Think of
by 3
rectangle.
p.m. Make sure you have your teacher
going
recommendation
3
form
meters per second
and
at
a
least
basic
for 8
essay
seconds.
resume.
It goes at
Any
least
questions, stop by counseling.
24 meters.
JCEA
Okay?
Hamburger Scholarship
Now,
worth up to
if
$10,000 over 4 years.
x
Focuses on
at 7, x at, sorry, 8 is x at 0 plus the change,
supports future pre-K through 12th grade educators. Most scholarship deadlines have been extended until April.
then x at 8 must be at least 7 plus
Each
24
month,
units
coaches have the
or,
opportunity to nominate athletes for
30
Student Athlete of the Month.
and
In
therefore
order to be
greater
selected for
than,
this prestigious award, athletes must be academically eligible every week and make significant contributions to their
that's
teams
how
and
it's
units
done.
and
You can
coaches.
say it a little differently. That's,
Esther's
I would say
dedication
it
to
now.
track and field is
Okay.
apparent, and she always competes at a high competitive level. Over the
this
winter, Esther
was,
school and club track
we got negative 73/40 meters per second, and this is the average velocity in meters per second.
Whether Esther is running 100 meters, the hurdles, or as a participant in a
Yeah,
relay,
it's Esther.
she always is willing to do whatever helps her
Let's
team
talk about Esther.
to their best. She has the heart of a true competitor, and she's setting the goal. Esther is definitely deserving of the honor that the student athlete of the month provides. Congratulations, Esther. Esther was nominated by Coach Porter.
The male student athlete of the month let's work diligently in the offseason. Our top distance runner in triple jumper. Triple jump is
7 over 25 meters per second is the average speed.
an example to all of our runners that they can see the results of diligent, sustained effort. Also, those in the classroom,
Okay,
congratulations.
that's what I feel like. How'd that go?
Just a reminder, Peaceful Schools is today and report to Miss McDivitt prior to 7th hour.
Also, don't forget to sign up for 7th hour for 135. That's all you have to. Have a great day.
135. Say 140. All right, make sure I get that by the end of the day. Have a lovely day. If you want to start working on test prep, just come in today or tomorrow or whatever. What? Extra practice and test reviews. Piecewise, that says piecewise extra practice. It'll be pretty light, and we will also go over the note sections in the review.
And I'll give you 10%.